Hello everyone, my name is Hassam and today I'm gonna go over finding the pressure altitude. So as we know, we pilots we want to know the pressure altitude. Why the pressure altitude is important for us? Because with the pressure altitude and combination of the outside temperature, we can find the density altitude, and finally the density altitude will help us to calculate our performance. We're going to talk about the performance in a different session in later on videos. So we just want to know that the pressure altitude will help us to with the combination of the outside temperature will give the density altitude, and density altitude is what that can help us to calculate our performance. Let's go over some definitions first. Then we're going to talk about the standard pressure, and finally we're going to talk about the pressure altitude itself. Let's start with the definitions. The pressure altitude, first we're going to understand what is pressure. Pressure actually is the weight of the air above us and all around us. It's the weight of the molecules of the air all around us and all above us. We know that the molecules of the air cannot be seen, but they have mass and they have weight, and they are pulling down toward the because of the gravity of the Earth. They are pulling down toward the surface of the Earth. And as we go higher, we lose about 1 inch of mercury. We measure the pressure by the gauge of inches of mercury, and we know that as we climb 1,000 feet from the surface, from the sea level, we lose about 1 inch of mercury. Standard pressure at sea level, it's 29.92 inches of mercury. And also we know that we have this the same standard we have for the temperature. The standard temperature at sea level is 15 degrees Celsius or 65 degrees Fahrenheit, but the standard pressure at sea level, it's internationally has accepted the 29.92. So as we know, we climb up 1,000 feet, we lose about 1 inch. So 1 inch per 1,000 feet of altitude gain. This is called standard lapse rate. So with that lapse rate, we're gonna find how far we are above that standard pressure, or 29.92. So let's talk about the pressure altitude, the big definition itself. The pressure altitude is the height above standard datum plane. So what do we mean by standard datum plane? Let's look at this example. Let's imagine this is the sea and this is sea level, and we are there is some land, and we are right here above about 1,000 feet MSL, mean sea level, above sea level, and this is our true altitude. So if this is on a standard day, the pressure of the standard pressure, it's going to be at the sea level, it's going to be 29.92, and at our altitude, when we gain 1,000 feet, it's going to drop by 1 inch. So as you can see here, by 1,000 feet of altitude gain, we lose about 1 inch. So if 2992 is at standard at sea level, we lose 1 inch, it's going to be 28.92. However, every day is not a standard day. It's frequent that you have here that the high pressure system is moving along, or the low pressure is coming around. So let's look at a different example. Let's see that the high pressure system exists around, and our standard sea level pressure is 30.42 today. And by this example, do you think that 2992 would be above this or below this? Yes, the 2992 would be above this because we lose pressure as we climb. So 2992 would be somewhere above it. But how far above it? So if we take the difference between this value and 29.92, which is the standard, we have the standard pressure right here. So if we take the difference, we're going to find that it is only 0.5 inches a difference. So if 1 inch is 1000 feet, so 0.5 inch is 500 feet. So we are technically, the line of 2992 would be right here, 500 feet above the standard pressure. So our airplane is actually 500 feet above that line. So our pressure altitude in this case would be 500 feet. So let's look at a different example. Let's imagine that a lower pressure system exists, and the sea level pressure at sea level pressure at today is at 29.82. So if sea level pressure is 2982, would the 2992 be here or here? Would be above it or below it? Yes, we know that we lose pressure as we gain altitude. So 29.92 would be down here somewhere. So how far below it? Below this 2982. So we want to find out how far. How we can find it? Again, we can use this lapse rate. So we can find the difference between the standard and the sea level pressure, and if we take the difference between them, we see that there is a 0.1 inch difference between them. So again, if 1 inch is 1000 feet, 0.1 inch is only 100 feet. So it actually adds to our altitude. So if this is our altitude from the sea level, it adds to our altitude by 100 feet, and our pressure altitude would be 1100 feet today. And there is another method to find the pressure altitude. If you're mathematically inclined, you can take the standard pressure minus the sea level pressure, times that by 1000, and if you add that to your field elevation or your true altitude as shown here, you can find the pressure altitude. So this is basically the formula for finding the pressure altitude if you are mathematically inclined. But as simple as it gets, wherever this 2992 is, your altitude, your height above it would be your pressure altitude. Thank you so much for watching.